Hey guys, what's up? We're just going to go on 8-3 here. This kid Kane has 4 pieces of wood. We're going to draw triangles with given conditions today, so super fun. Or maybe not draw necessarily all of them, but we're going to talk about it. Kane has 4 pieces of wood available to build a triangle shaped garden. What pieces of wood can he use? So these are the 4 pieces of wood he can use. Now, what you got to realize is you kind of got to take the shapes and compare them to each other, right? And the idea here is that 2 and 3 and 4 will work. 3 and 4 and 5 will work, but 2 and 3 and 5 will not, right? And the reason is, let's kind of break this down, is that this 5 foot length, if I compare it to inches, right? And I make say 1 inch per, 1 inch per foot. And I do, let's see if I can. Okay, so I have 5 inches right here, right? Okay, now 4 inches, if I kind of draw it out, I'm just going to draw them out kind of all parallel to each other, right? I've got 4 inches right here. And this is, again, we'll do 1 inch equals 1 foot. Okay, so this is 4 inches. And then we'll do, what is it, 3 and 2? Yeah, we'll do 3 inches versus 2 inches. Okay. Okay. Gosh, you didn't see me draw those at all. But anyway, this is 2 inches, 3 inches, 4 inches, 5 inches. Okay. And the idea here is that 4 and 3 add up to a bigger number than 5, right? 2 and 4 add up to a bigger number than 5, but 2 and 3 don't add up to a bigger number than 5. So if I draw like a 3 inch right here, that gets right there. Okay. And then I've got 2 inches on the other side. So I've got 3 inches here and 2 inches here. They don't come up to make a triangle, right? They basically, there's no way that you can make that angle between those, right? So there would always be a gap, right? So if I kind of draw it out right here, okay. Again, this is that garden, right? 5 inches, and I try to kind of get it, get a really shallow angle, right? I get 3 inches right here, and I get 2 inches right here. They're never going to connect, right? So I'm going to have a gap on the wall, right? So that's 3, this is 5, this is 2. No matter what, they're never going to connect at an angle. It's always going to connect at a straight line, right? So, so yeah, that 2 inch, 3 inch, and 5 inch pieces of wood would not form a triangle. So 2, 3, and 5 inch pieces of wood would not form a triangle. And that's kind of the idea with this unit is basically, are your side lengths long enough to connect together? And that 2, 3, and 5 don't connect together, no matter what you're going to do. Okay. So similar idea here. Steve gathers 3 pieces of wood from the scrap pile and woodshop class. Can Steve make a triangle with these 3 wood pieces? Again, we're going to do that same thing, right? Shoot, I should be doing centimeters, not inches, because inches are too long. So I'm going to we'll do 8. We'll do 1 centimeter equals 1 foot will be our scale right here. We're going to do that same thing, right? So I'm going to do 8 centimeters. Let me see this, yeah. Right there, so that's 8 centimeters. Okay, again, 3, if I draw 3 centimeters right here, I'll just kind of do it above it. So that's 3 oh man, if I could actually write, that would be great, right? So that's 3. And then if I go 4 centimeters from the edge here, okay, that's same idea, right? They're never going to connect. You'll always have this gap right here, even if you try to draw them straight, right? So, no, these pieces would not make a triangle. Okay. And then what can we conclude about the lengths that make a triangle possible? Well, the two shorter sides of a triangle have to be longer than the third side. Have to be longer together. That's the important part, right? Than the longest side alone. Okay, so the two shorter sides of a triangle, it should be singular, have to be longer together than the longest side alone. Okay, so 3 and 4 are not greater than 8. 3 and 4 is 7, right? So it's not greater than 8. If it was 3 and 5, for instance, well, actually, no, it'd have to be like 4 and 5, because that would get you to 9, right? So that would be longer than that longest side. Okay, draw a triangle with 3 given angle measures. So 30, 60, 90. I'm going to do... let's see here. It's going to be the easiest way to do this. Let's just start with let's do 3 centimeters. Boom, right there. Okay. And we'll do a 90-degree triangle out. Let's see. What's going to be the easiest way to do it? So we'll do a 90-degree right here. Oh man, my other triangle. My other protractor got lost, so I don't know where it is here, unfortunately. It's going to go like right out there. Okay, so it's going to go on that line right there. I'm actually going to draw these lines out pretty long, and then I'm going to start here. I'll do the 60-degree here, so out. Where is that 60? Boom, boom, boom. There it is. Down there. Okay. So right there, and that way we have our 90-degree right here, we have our 60-degree right here, and we have our 30-degree right here. One thing you should notice: 90 plus 60 plus 30 equals 180. Okay, that'll come in important later. Okay, so we've got that one. Now let's actually make a larger size because we're looking for a unique triangle, which, right? So definitely have the longer side right there. Now let's see if we can make another 60-degree angle right here. Did I get that right? Let's see, 60. Goes out to, yeah, that's right. Where did I put it at? Oh, you know what I did? I think I went out to the wrong one, but it's fine. Well, did I? Let me see here. That should be, oh, I think I went out to 30 degrees. I got them reversed. That should be a 30. My bad. Sorry, if you were actually contemplating that, that should be 30 right there. That should be 60. My bad. Okay, so let's do a 30-degree angle out here, which would be like right here. So let's connect that. Boom. Okay. So we got a 30-degree angle right here. Maybe. Gosh, sorry, I keep pulling it off, guys, and you can't see me right here. So a 30-degree angle right here, a 60-degree angle right here, and again, we have that 90-degree angle right there. So we have this one here with the same angle measurements and this one here, but they're different sizes, right? So the idea is that there a unique triangle with these angle measurements? No, there is not. You can make basically any size triangle you want with these, right? So no, there isn't a unique triangle with those angle measurements. Okay? Because you can basically make any size triangle you want as long as you are keeping the angle measurements the same. Okay. So yeah, we have this triangle right here, which the same angle measurements but different sizes, right? So it's the same shape, just different sizes. Okay, which will come into play in 8th grade. Okay, determine possible angles of triangles. Can this group of three angles be the angles of a triangle, right? So I have 50, 60, and 140. I'm just going to cut to the chase here, guys. This is kind of an 8th grade standard, but I figure it'll be easier for you guys to contemplate this than what's in the workbook, because the workbook is all about drawing this stuff, and we're not testing you on drawing this stuff. But the idea here is you add these up, right? And if you get to 180 on the dot, boom, it's a triangle. If you get below it, then your lines won't connect. And if you get above it, then it's some other kind of they won't connect either, because you would need a fourth side to do it. So 50 plus 60 plus 40, that is 150 degrees. So that will not get you to a triangle, right? If we look at this one, this 40, 50, 90, 40 plus 50 is 90, plus 90 is 180. So only if it's 180 on the dot will it be a triangle. This is not a triangle. Okay, this is a triangle because the three angles have to add up to 180. Okay, there you go.